Hello, fabulous 4th grade parents, and welcome to Parent Quick Smart, Episode 7, Adding and Subtracting Fractions for Unit 7.
In this unit of study, students will be adding and subtracting fractions with like denominators. Just like all of our other work with fractions, we're going to start first with an emphasis on models and drawing pictures. This will help students build conceptual understanding of adding and subtracting fractions before moving on to more difficult concepts. Let's look at some examples. We have 2/8 plus 3/8 equals 5/8. Now in the past, you were probably taught to just add the numerators and leave the denominators the same. Now that's something we want students to eventually realize, but they'll realize this through the exploration of models. We can see they have 2/8 here, and 2/8 is really 2 eighth-size pieces. And we have 3/8 here, so if we count them up, that's 1, 2, 3, 4, 5/8. It's just like saying 2 pencils plus 3 pencils equals 5 pencils. 2/8 plus 3/8 equals 5/8. We didn't change the size of the piece. Let's look at a subtraction problem. So we have 6/10, and we want to subtract 4/10. So we have 1, 2, 3, 4/10. We have 2/10 left. So 6/10 minus 4/10 equals 2/10. Next, students will move into working with mixed numbers and fractions greater than 1. It's important that we introduce precise vocabulary with our students. You were probably taught that if the numerator was more than the denominator, it was called an improper fraction, and you probably were taught that you immediately needed to change that to a mixed number. That's not the case anymore. If the numerator is more than the denominator, that simply means that that is a fraction greater than 1. And students can use fractions greater than 1, it's just not in its simplest form. Now, let's talk about how students can rename those fractions greater than 1 as a mixed number, and how they can rename mixed numbers as fractions greater than 1. So we'll start with 7/5. You can see the student has 1, 2, 3, 4, 5, 6, 7/5 strips. The student can replace the 5 of those strips with 1 whole, and they have 2/5 left over. So 7/5 is the same as 1 2/5. Let's look at how students could do this on a number line instead of using fraction strips. The student could draw their number line out, and then they could section off 5/5 is 1 whole, and count how many more fifths it takes to get to 2 wholes. So we have 1 whole and 2/5. Now students can go the opposite way too. If they modeled 1 whole and 2/5, they could rename or replace that 1 whole with 5/5, and then count up 2 more fifths to equal 7/5. Let's see what that would look like on a number line. So students would have 0, 1, and 2, because they know 1 2/5 is in between 1 and 2, and then they would break their number line into fifths. They would find 1 2/5 on their number line, and then just count the number of fifths it takes to make 1 2/5, and we have 7/5. Now students are going to need to take their knowledge of renaming fractions greater than 1 and mixed numbers when they start adding and subtracting with those mixed numbers. Let's look at some examples. So we have 1 4/6 plus 2 3/6. Let's start with a model first. You can see we drew 1 whole and 4/6 and 2 wholes and 3/6. And so let's count that up. We have 1, 2, 3 wholes. We can take these 1, 2, 3, 4, 5, 6, 7, 6, and we can regroup them to make 1 whole and 1/6. So that's a total of 4 wholes and 1/6. Let's see what that would look like on a number line. We would start by breaking our number line apart into sixths, and we would find 1 4/6. The next thing we're going to do is jump 2 wholes. So we're going to jump 1 whole, which is 6/6. So 1, 2, 3, 4, 5, 6. A second whole, and then 3/6. 1, 2, 3. And we find that our total is 4 1/6. Finally, students will learn to add mixed numbers using a more traditional algorithm that's like what we used when we added whole numbers. We're going to start in the lowest place value, or the place value all the way to the right, which is our fractions place. 4/6 plus 3/6 equals 7/6. Well, students know that's greater than 1. just like when they're adding and subtracting whole numbers, they're going to need to regroup. We know that 7/6 is really equal to 1 and 1/6. So we're going to record the fraction 1/6, and we're going to regroup the ones into the ones place value. 1 plus 1 is 2, plus 2 more is 4. So our total is 4 and 1/6. Now students are going to move into subtraction with mixed numbers. Let's try 2 and 1/4 minus 1 and 3/4. We have 2 wholes and 1/4. Now I want to subtract 3/4, but I only have 1/4 here. So I'm going to need to regroup this whole into fourths so I can subtract 3/4. Now I can cross out 3/4 and cross out 1 whole because I'm subtracting 1 whole and 3/4. All that's left is 2/4, which we know can be renamed or put in simplest form as 1/2. Now let's see what that would look like on a number line. We're going to start at 2 and 1/4, and we're going to count backwards until we get to 1 and 3/4. Our difference is 2/4, which, as we said before, could be renamed as 1/2. Finally, let's subtract like we would with place value. 1/4 minus 3/4. Well, I don't have enough fourths, so I'm going to need to regroup. So I'm going to take 1 whole from the ones column, and I'm going to bring it over as 4/4. Now, I already had 1/4 there. 1/4 plus 4/4 equals 5/4. 5/4 minus 3/4 equals 2/4. 1 whole minus 1 whole equals no wholes. Now we know 2/4 can be renamed as 1/2. One final strategy for subtracting with mixed numbers is to rename both mixed numbers as fractions greater than 1. We know that 2 and 1/4 is equal to 8/4 and 1/4, which is 9/4. And we know that 1 and 3/4 is equal to 4/4 and 3/4, which is 7/4. Subtract those and we have 2/4, which can also be renamed as 1/2. Here are some questions to ask your child as they're working through addition and subtraction with fractions. Real-world connections for fractions are everywhere. Let's say we were in class and we know that 9/20 of our class have cats and 7/20 of our class has a dog. What fraction of our class has pets? If we know that we have 5/8 of a tank of gas in our car and we know that our trip is going to take us 3/8 of a tank to get there, what fraction of the tank will we have left when we get back? If we're at a family gathering and we have pie for dessert and Uncle Joe eats 2/4 of our pie, what fraction of the pie is remaining? Thanks for tuning in. Remember to keep in communication with your child's teacher and to check out these cool links for more information. See you next time.